Okay. Now we're going to look at a slightly more complicated form of partial fractions, but everything we do is going to be pretty familiar. It's just you're going to end up with maybe 4 equations and 4 unknowns, but they won't be difficult equations. Okay, so what we have is we have a denominator, a linear term squared, and times another linear term squared. Okay? Well, what we do is fairly straightforward on the first step. Since we have x minus 2 squared, we're going to do a over x minus 2 plus b over x minus 2 quantity squared. And then we have an x plus 3 cubed. We're going to do a c over x plus 3 plus d over x plus 3 squared. Now, to get our common denominator, well, our common denominator is going to just be x minus 2 squared times x plus 3 squared. Excuse me, so we've got x minus 2 here. What else do we need? Well, we need another x minus 2, so we've got to multiply that by x minus 2 over x minus 2. Of course, we also need an x plus 3 squared. Now, should be nothing difficult in this step. You might want to think about it before we go on and anticipate what we're going to need to do with the other terms. Okay? Well, now, to get b over the quantity x minus 2 squared into a form with a fraction with the denominator equal to this original denominator, we don't need to do quite as much. We've already got x minus 2 squared, so all we have to do is multiply by x plus 3 squared over x plus 3 squared. And then to that, we do the c over x plus 3. Well, we've got an x plus 3, we need another one, and we need an x minus 2 squared. So we do c over x plus 3 times x plus 3 over x plus 3 times x minus 2 squared over x minus 2 squared. So now we have the same denominator. And then we do plus d over x plus 3 quantity squared times x minus 2 quantity squared over x minus 2 quantity squared. Now that's not really a mess, but it's a fair amount of calculation. And I'm not going to fumble through this on screen, okay? I mean, I think x plus 3 squared is x squared plus 3x plus 9, 6x plus 9, see what I mean? And you multiply that by x, you multiply that by minus 2, and you add up what you've got, okay? Don't want to do that in my head. Actually, I will do it in my head, but I'm going to do it off screen, and then we'll come back and see where this goes. But you see what's going to happen is you're going to have an a times a cubic polynomial, and you're going to have a b times a quadratic polynomial, and you're going to have a c times a cubic polynomial, meaning, among other things, you're going to have an ax cubed plus cx cubed, meaning that a plus c is going to have to equal 2, isn't it? Okay? Well, with the lower order terms, you get a lot more complication. So let's see how it works out. Now, I'll write out the rest, and then we'll continue.